number 10, 11, 11, 12, 13.
Yes, sir.
Okay, 14, 15, 16.
Present, sir.
Okay, 17, 18, 19, 20.
Yes, sir.
Okay, 21, 22, 23, 24, 25.
Present, sir.
Okay, 26, 27, 28, 29, 30.
Present, sir.
Okay, 31, 32, 33, 34, 35, 36. Pratmesh, Joslino, Soham, Atia,
Yes, sir.
Shweta.
Present, sir.
Okay, Deepa.
Present, sir.
Okay, Hanumant, Ilyas.
Present, sir.
Okay, anybody else?
Sir, Prajwal Mali.
Prajwal Mali. Okay,
हाँ सर.
okay. Anybody
Sir,
else?
Prathamesh Kinekar. Sir, Prathamesh Kinekar.
Okay, okay.
Sir, Karthik Patel.
1 minute. Okay, anybody else? Karthik Patel.
Sohail
Then
Sayed.
Karthik Patel.
Sohail
Sayed.
Sayed. Okay, anybody else?
Rohit Mutigi.
Rohit Mutagi. Okay,
Sridhar Patil, sir.
Sridhar Patil. Right. Anybody else?
विशाल वसुलकर.
Vishal
वसुलकर.
Vasulkar. Okay, anybody else?
Sir Sampath.
Sampath. Okay, anybody else? Okay, fine. Regular students, anybody joined? Regular students? Sai Prakash, Ankita. Okay. Sai Prakash. Then who else joined? Quickly. Regular students. One is Ankita, another one is Sai Prakash. Then anybody else joined? Okay.
Sir 19, sir.
Roll number 19. Right. Sai Prakash I have marked. Anybody else? Okay. Who is Khan here? Somebody Khan is there?
Yeah, sir. Sohail Sayed.
Soil said. Okay. Okay.
Yeah.
Okay. Right. Okay. In the last class, I was just about to begin with the module 4, right? So this module 4 is all about the power amplifiers. Now, what are these power amplifiers? Are you able to see the screen, students? Screen is visible?
Yes, sir.
Okay. Now, the name amplifier, what is amplifier? I told in the last class. What is amplifier? Amplifier is a circuit which increases the magnitude of the applied input signal. That is, output signal magnitude is more than the input signal magnitude. Such circuits are called as amplifier circuits. Such circuits are called as amplifier circuits. Okay. Now, power amplifier are the circuits which provide sufficient power, that is, output power is more than the input power. So, such circuits are called as power amplifier circuits. So, they provide enough power or sufficient power to the output load. Okay. So, such other circuits are called as power amplifiers. Now these power amplifiers, when they are used in the radio system or television system, they provide sufficient power to the load, and the load that is used in the radio system or the television system is the loudspeaker. So they provide high power to the load, that is the loudspeaker that is used in the radio or television system. Okay. Then these amplifier circuits, they are used for handling large voltage signals. There are two types of signals. One is small signals and another one is large signals. Small signals are in the range of few volts or microvolts or millivolts, whereas the large voltage signals are in the values of or in the magnitude of few volts. Right? The small signals are in the magnitude of microvolts or millivolts, whereas the large signals, they are in the range of few volts. Okay. So that is the difference between small signal and the large signals. So these amplifier circuits, that is in particular power amplifier circuits, they are used to handle large voltage signals which are at the moderate or high current levels. So they are meant to handle large voltage signals, that is the signals which are in terms of volts. Such signals are handled by the power amplifier circuits. There are certain features of power amplifier circuits. So one of the feature of the power amplifier circuit is power efficiency. Efficiency, as we know that it is the ratio of output to input. Okay. So when it is power efficiency, it means that it is the ratio of output power to input power. The ratio of output power to input power is called as the power efficiency. Right. Then the maximum amount of power that the circuit can handle, that is how much maximum current that the circuit can handle, or how much maximum voltage that the circuit can handle, the product of voltage and the current, that is the maximum amount of power handling capacity of the circuit, and the impedance matching with the output device. Impedance matching is the output impedance of the power amplifiers should match with the input impedance of the load. The output resistance or impedance of the power amplifier should match with the input resistance or input impedance of the load. Right? This you will be studying in your electric circuits in your network analysis. It is called as maximum power transfer. There is a theorem on that called as maximum power transfer theorem, which states that the maximum power will be transferred to the load whenever the output impedance of the circuit matches with the input impedance of the next subsequent circuit. Okay. When the output impedance of the power amplifier matches with the input impedance of the load, then the maximum power will be transferred to the load. Okay. These are the features of the power amplifier, that is power efficiency, the maximum power handling capacity of the circuit of the power amplifier, and the third one, the impedance matching with the output load or the output device. Next comes the classification of power amplifiers. How to classify the power amplifiers? Power amplifiers classes, they are meant to represent for what portion of the applied input signal we are getting the output signal. Right? Based on how much portion of the output signal we are getting at the output for the applied input signal cycle, that is used to classify the power amplifiers. That is used to classify the power amplifiers. So there are different types of power amplifiers, that is class A amplifier, class B, class AB, class C, and class D power amplifiers. Right? These power amplifiers are classified based on how much portion of the applied input signal is available at the output cycle, or at the output how much amount of cycle of the applied input signal is available. That decides whether it is class A or class B or class AB or class C or class D power amplifiers. Then there is one more amplifier called as class D amplifier. This class D amplifier is one which makes use of the applied digital input signals. It works on digital input signals or digital pulse signals. Pulse signals or the digital signals which is used in the class D amplifiers. So such of the amplifiers are called as class D amplifiers. Let us see individually what are these different class A, what is meant by class A, what is class B, class AB, class C, and class D power amplifiers. In the class A power amplifier, the output signal varies for full 360-degree cycle of the input. The output signal varies for full 360-degree cycle of the applied input waveform. So such of the amplifiers are called as class A amplifiers. Okay. If you look into this figure, the output is varying for one complete cycle, that is 0 to 180-degree half cycle and 180-degree to 360-degree next half cycle, or the negative half cycle. So it varies from 0 to 360-degree of the applied input signal. So such of the amplifiers are called as class A power amplifiers. Such of the amplifiers are called as class A power amplifiers. Okay. So in this class A amplifiers, the DC voltage or the biasing voltage, there is a term called as biasing voltage here. So the biasing voltage means the voltage, DC voltages that we are applying in the circuit in order to make the transistor or the circuit to operate properly. How much amount of DC voltage if we apply, the circuit or the transistor will work properly, so that the output is varying linearly with respect to input. The gain of the transistor or the gain of the circuit is maximum, and the amplification of the transistor or the amplification of the circuit is maximum. Okay. So to obtain these characteristics or features, we are required to apply certain DC voltages to the circuit or to the transistor circuits. Okay. So that is called as bias level, or the DC bias level, that is required to apply certain DC voltages so that the transistors or the circuits operate linearly with respect to input. There is suitable amplification of the applied input signal, high gain, that is output voltage by input voltage is high, ratio is high. So such characteristics are obtained by applying suitable DC bias levels. So the DC bias level for the class A amplifier is in between, that is, you can see it is above the zero level. Okay, it is above the zero level here, right? Then the swing, the positive swing is less than the power supply level. The positive swing is less than the output power supply level. Power supply level, say it is, suppose it is 12 volts. So this the positive peak of the class A output may be 10 volts. So it is slightly less than the power supply signal level, and that is the negative peak is more than the 0 volts. This is 0 volts here, the ground level. The negative peak is more than the 0 volts level. So such of the amplifiers are called as class A power amplifiers. So the figure below shows that the required Q point, that is quiescent point, or the DC bias level, is at least half the signal swing of the output may vary up and down without going to a high enough voltage, which is limited by the supply voltage level. That is, this high peak, the positive peak, is limited by the power supply level. It is less than the power supply level, and the lower supply level, or the lower supply level is more than the 0 volts. Okay. So such of the amplifiers are called class A amplifiers. They operate for one full cycle of the applied input signal, right? Are you following here, students? Are you following here? Yes. Are you
Yes, sir.
following here? Okay.
Yes, sir.
Fine.
Yes, sir.
Good, good. Okay. So next, class B power amplifiers. So in this class B power amplifiers, so first we saw the class A power amplifier, right? Then next is class B. In the class B amplifier, as you can see in the second figure, the DC bias level, the DC voltage level that is applied to the circuit for proper operation of the circuit or the transistor, it is at the 0 level. Okay, it is at the 0 volts, right? The DC bias level, and the operating cycle of the power amplifier in class B, it is 180 degree, 0 to 180 degree. So it is half the cycle. Okay, half the cycle. That is the operating range or the operating cycle of the power amplifier in class B. It is from 0 to 180 degrees, half the positive portion of the applied input signal. A class B circuit provides the output signal varying over one half of the input signal, which is shown in the below figure. The DC point is at 0 volts, right? The DC voltage, it is at 0 volts level, with the output varying from this bias point for half cycle. The output varies from 0 volt level for the half cycle, that is 0 to 180 degrees. That means what here? Is it a faithful reproduction of the applied input signal? Applied input signal is a one full cycle. It is a AC signal, one full cycle, the output that we are getting is only half of the applied input signal. Correct? That means it is not the faithful reproduction of the applied input signal. Okay, it is not the faithful reproduction of the applied input signal. Whatever input signal we are applying, it is one full complete cycle, but the output that we are getting is only half cycle. That means it is a distorted waveform. It is a distorted waveform because we are not getting one complete cycle. So what is done here is, if we want to get one full complete cycle, two such class B power amplifiers are connected, right? Two such class B power amplifiers are connected, so that the first class B power amplifier, it provides first half cycle, positive half cycle, and the second class B power amplifier, it provides the negative half cycle. So both the two class B amplifiers are used so that it provides one full complete output cycle. It provides one full complete output cycle. Okay. So such of the amplifier circuits or connections are called push-pull amplifier circuits. They're called as push-pull amplifier circuits or push-pull operation, which provide one full 360-degree of operation. Okay. That is class B operation. It creates a distorted output signal because it is not the faithful reproduction of the applied input signal. Next is class AB power amplifiers. Class AB power amplifiers. As in this, the name itself suggests that it is class AB, means it is neither class A nor class B. That means it falls in between that of the class A and class B power amplifiers. Okay, so this class AB power amplifier, it falls in between that of the class A and class B power amplifiers. So it is biased at a DC level. So the biasing level of the class AB is above the 0 volts, okay, above the 0 volts and above the positive power supply voltage. Okay, above this power supply level and above the 0 volts level. That is the range in which the class AB power amplifier works. Okay. An amplifier may be biased at DC level above the 0 base current level of class B and above 1/2 of the supply voltage level of class A. Okay, this is called as class AB power amplifier. Now, thus class AB also requires a push-pull connection so that we get one full complete cycle, because it is also producing almost half cycle. Therefore, if you want the one full complete cycle, we should connect two such class AB power amplifiers in push-pull connection. Push-pull connection means what? One class AB power amplifier provides one half cycle, another class AB power amplifier provides the negative half cycle or the another half cycle. So both together combined will produce one full complete cycle of the output from 0 to 360 degrees. Okay, so the class AB of power amplifiers also requires push-pull connection to achieve one full output cycle, but the DC level is close to 0 base current level. If we look into the class AB power amplifiers, the DC bias level, it is closer to 0 base current level. It is closer to the DC, that is 0 base current level here. It is just above the 0 base current level. So because of this, the power efficiency will be good. Okay, because it is above the 0 volts level here. So as it is above the 0 volts level, okay, so it is nearer to the one full cycle. It is nearer to the one full cycle. It is not like class A power amplifier. Okay, in class A power amplifier, it is above the 0 volts. It is above the 0 volts. So it is not producing exact cycle as that of the input. Correct? Even though it is a full cycle, but it is not touching the 0 volts level. But in class AB power amplifier, what is happening is touching almost nearer to the 0 volts level. Okay, so because of this, there is the output that we are getting is good, right? Output voltage is maximum, and because of this, the efficiency of the class AB amplifiers or class AB power amplifiers will also be good. The DC bias level is closer to 0 base current level, and hence the efficiency of the class AB power amplifiers will be good. Okay. The output signal swing. What is the swing of the output signal here? It is in between 180 degree to 360 degree. For class AB power amplifier, the output voltage swing is in between 180 degree to 360 degree, between 180 to 360 degrees. Okay, in between that of class A and class B power amplifiers. So it is neither in class A nor it is classified as class B. It is in between that of class A and class B. The output voltage swing is between 180 to 360 degrees. Next is class C power amplifiers. So in the output of a class C amplifier is biased for operation at less than 180 degree cycle, 180 degree of the cycle. Okay. So this class C amplifiers, it operating cycle is less than 180 degrees, and it makes use of tuned circuit. Okay. It makes use of tuned circuit or resonant circuit for providing one full cycle of operation. Now, resonant circuit you might have studied in your physics in your PU level, right? So the resonant circuit is a circuit in which it's a combination of RLC, that is resistance, inductance, and capacitance. When the resistance value, capacitance, and inductance values are adjusted such that at one particular frequency value there is a peak, right? A peak signal is obtained, a maximum output signal is obtained for one particular frequency, and that is called as the resonance condition. That is called as the resonance condition or the resonant circuit. So this class C amplifiers, they are combined with the tuned circuit or resonant circuit to provide one full cycle of operation, so that the class C amplifiers independently they don't work. They have to be used along with the tuned circuit or resonant circuit to provide one full cycle of the operation. Now, as they are using the tuned circuit or resonant circuit, they are used in the areas of radio systems and in communication systems. They are used in the areas of the radio systems and the communication systems, which make use of the resonant circuits. Okay, that is the application of the class C type of power amplifiers. Then class D amplifier, the class D amplifier. So in this class D amplifiers, the amplifier operates with the input signals, the signals that are used in the class D power amplifiers, they are the digital signals or the pulses. Right? They are the digital signals or the pulses, and the on time of these digital or pulse signals is less, the off time is more. We know what is a pulse, right? A digital signal, a pulse, which varies from, it has a low level and the high level. There is a difference between analog signal and the digital signal. Analog signal is continuous. It varies from 0 to 360 degrees continuously. It's a smooth signal. Whereas digital signal, it has only two levels. One is 0 volts, another one is high. One is low, another one is high. 0 volts, 5 volts, or 0 and 1 in binary. Okay. So it has only two levels. Is it not? Digital signal. So such signals are made use of in the class D power amplifier circuits. Okay. So in this class D power amplifier circuits, they make use of digital techniques. They make use of digital techniques to provide one full cycle of operation. Okay. Now, what are the digital techniques that are employed or that are used here? They make use of sample and hold circuit in class D power amplifiers. Sample and hold circuits are the circuits. Okay. So these sample and hold circuits, if it is a continuous analog signal, then that analog signal is sampled. Okay, it is cut into pieces. The applied analog input signal, which is continuous, is cut into pieces. Right? Say at 0 volts, 1 volt. Suppose if it is 0 to plus 5 volts and minus 5 volt signal, then at 1 volt there is a small sampling. It is cut into piece. At 2 volts, 3 volts interval, 4 volts interval, 5 volts interval is cut into pieces. Okay, that is, it is called as sampling. Right? Then this sample signal is held constant. Whatever we are cutting into pieces, this applied input analog signal, that is held constant for certain time. This is called as hold. This is nothing but sample and hold circuit. You'll be studying this later in your other subjects later in your higher semesters. But now, what is sample and hold circuit? It is a circuit which samples or cuts into pieces the applied continuous input signal, and these cut pieces of the applied analog input signal is held constant. It is maintained constant for certain time, and that is called as hold period or the holding. Okay, so the combined, it is called as sample and hold circuit. Now, why this sample and hold circuit is necessary is this output of the sample and hold circuit is applied to analog to digital converters, ADC. That is, it is a ADC is a circuit which converts the applied analog signal into digital signal output. Okay, applied analog signal is converted into digital output signal. So such circuits are called analog to digital converters, right? So this sample and hold circuit is used so that for the ADC, if you want to apply the analog signal, that is input to the ADC circuit, then there should be certain constant signal. Okay, so that constant signal is performed, or it is obtained with the help of this sample and hold circuit, because we are sampling the signal and we are maintaining that signal, sampled signal or the cut signal, constant for certain time. Okay, then it is applied to the analog to digital converter, which is a constant signal. So that analog to digital converter will convert this signal of the output of the sample and hold into a digital output. Okay, so this is the digital technique that is used in the class D type of power amplifiers. So is this classification clear, students? In examination they may ask, classify the power amplifiers. What are power amplifiers, or define power amplifiers, and then write the classification of power amplifiers. So you have to first define what are power amplifier, or what is a power amplifier, and then you have to classify them: class A, class B, class AB, class C, and class D. Then write explanation in few sentences for class A, class B, class AB, class C, and class D power amplifiers. Is it clear here, students? This classification of power amplifiers. Any doubts here? Classification of power amplifiers. Any doubts? Are you understanding the concepts here?
Yes, sir. No doubts.
Okay, fine. What about others? Others
Yes, sir. Yes.
following?
Sir.
Fine. Atiya, following here. Atiya, Shweta,
Yes, sir.
are you following here? Follow the concepts here.
Yes, sir.
Power amplifier or classification of power amplifiers.
Yes, sir.
Okay. Hanumant Patil, Ilyas,
Yes, sir.
following the
Yes.
concepts are clear.
Yes, sir. Yes.
Okay. Prathamesh K,
Yes, sir.
following here power amplifiers.
Yes, sir. Yes, sir.
Okay. Okay, good. Sohil Sayed,
Yes, sir. Yes, sir.
following this, these points you all understood. What are
Yeah.
different points on power amplifiers? Okay,
Yeah.
fine. Okay. Sridhar Patil, Sridhar, Vishal Vasolkar, Vishal, Rohit Mutagi.
Yes, sir.
Is it clear, Rohit? The points on power amplifiers.
Yes, sir.
Any doubts here?
No, sir.
Any problem in understanding?
No, sir.
Okay, fine. Sampath,
Yes, sir.
clear with the points, Sampath?
Yes, sir. Yes, sir.
Any problem in understanding?
No, sir.
Okay, fine. Chandrasekhar,
Sir, all clear, sir.
okay, fine. Janvi,
Yes, sir.
is it clear, Janvi, this power amplifiers topic?
Yes,
You all
sir.
understood? Okay, fine. Ratan,
Yes, sir. Yes.
did you understand the definition and classification of power amplifiers?
Yes, sir. Understood, sir.
Okay. Shiraj, Mujawar, Shubham,
Yes, sir.
is it clear, Shubham? What all I discussed till now? Okay.
Yes, sir.
Fine. Suraya Banu? Suraya Banu? Okay. So there is a little bit of more on power amplifiers. We'll take up that. Amplifier efficiency. Now, amplifier efficiency, as I told, efficiency means it is a ratio of output to input. Now, when we consider power efficiency, right? When we use the term power efficiency, that means it is a ratio of output power to input power. Okay, it is a ratio of output power to input power. That is called as power efficiency of an amplifier. So it is defined as the ratio of power output to power input. And this power efficiency, it is improving as we go from class A to class D. As we go from class A to class D power amplifiers, there is improvement in the power efficiency. Let us see the reason why it is improving from class A, right? And how it is in class A, okay, why it is less, right? And how it is improving for the other power amplifiers. Let us see that. Now in class A amplifiers, the DC bias is at 1/2 the supply voltage. That's what I told just now. The DC bias level in class A amplifiers, it is a 1/2 of the supply voltage level. Okay, if you look into this waveform, the DC bias level, it is exactly in the middle. It is not nearer to the zero level. And this power, it is utilized, or power is consumed in the circuit. In the circuit that we are employing in the transistor circuit, whatever this power is there, we are applying, that is consumed or that is dissipated in the transistor circuit. Okay, because it is not nearer to the zero level. So here it is, whatever power we are obtaining, that is wasted, or it is consumed, or the power is dissipated in the transistor circuits. So it is DC bias at 1/2 the supply voltage level. It is using good amount of power to maintain bias, to maintain the bias condition for proper operation of this circuit. It is using large amount of power for maintaining the bias condition. Bias condition means, I told that it is for applying the certain DC voltages so that the transistor works properly in the linear region. Linear region means output is linearly varying with respect to input, or the output is having more magnitude than the input magnitude, input signal magnitude. Okay, gain is high. The ratio of output to input is high. So such conditions are obtained only with the large amount of power, so that whatever power we are applying, that is nothing but utilized for maintaining the bias condition, and the output power will be reduced, output power will be decreased. So because of this, what is happening, the ratio of output power to input power will be less. Okay, the output power is less, and hence the ratio of output by output power by input power will also be decrease, it will be less, and that is why it is resulting in the poor efficiency, right? Efficiency of the class A power amplifier is less. Okay, so how much is the efficiency of the class A amplifier? It is only 25%. There are two types here. One is, it is called as direct or series fed load connection. Okay, we'll discuss that later in the next class. Direct or series fed load connection of class A amplifier, its efficiency is just 25%. And if it is using the transformer in the circuit, that is transformer connection to the load, then the efficiency increases, because the transformer is a circuit which provides one full complete cycle. Okay, step up or step down transformer, they are providing one full complete cycle of the output. Okay, so it increases if the transformer connection is used in the load connection, then the efficiency of the class A amplifier is increased to 50%. From 25% it is increased to 50%. Okay, class B operation, it provides maximum efficiency of 78.5%. Class B operation, as we are seeing that class B operation, it is nearer to the 0 volts level. So it is almost a good reproduction of the applied input signal at the output. So output is more, and hence the efficiency of the class B operation is more than that of class A, it is 78.5%. Then coming to the class D power amplifier, it has power efficiency of 90%. Okay, and it is most efficient among all the class amplifiers. Among all the power amplifier classes, the class D operation or the class D power amplifier is the having highest efficiency, that is 90%. Okay, so that is class D. So what is class D? It makes use of digital signals. Right? D means digital. Just remember like this. Class D operation, it makes use of digital signals or pulse signals, and it makes use of the sample and hold circuit. So we know that the efficiency, if it is using digital signals, is more than that of the analog signals, and hence the efficiency of the class D power amplifier is also more. It is 90%. Then class AB, it is in between that of class A and class B, just we discussed. Class AB is in between class A and class B type, and its efficiency is also in between class A and class B type. Class A efficiency is 25% or 50%, and class B efficiency is 78.5%. The efficiency of class AB is in between that of class A and that of class B power amplifiers. That is, it is in between 25 or 50% and the 78.5%. Then class C is not used for delivering large amounts of power. Okay, what is class C? Let us see. We have already gone through that. So class C, output of class C is biased for operation at less than 180 degree of the cycle. So it is not reproducing at least half of the input cycle also. The output cycle is less than 180 degree, and hence large amount of power cannot be obtained from the class C power amplifiers. Okay, because its output cycle is less than 180 degree, we cannot obtain more power from class C type of power amplifiers. Okay, and that is the reason it is less used, and hence its efficiency is not defined here, because the class C type of power amplifiers are less used or very less used for delivering large amount of power to the load. Okay, so that is about the efficiency, amplifier efficiency. One efficiency is about the class A, right? Class A efficiency is 25% or 50%. Class B efficiency is 78.5%. Class D efficiency is 90%. Class AB, it is in between A and B, that is 25 or 50% and 78.5%. And class C efficiency is not defined here because it is very less used for delivering large amounts of power to the load. Okay. In today's class, students, we have discussed the definition of power amplifiers. The definition of power amplifiers. What is a power amplifier? A power amplifier are circuits that provide sufficient power to the output load. That is, output power is more than the input power. Okay, so they are such of the amplifiers are called as power amplifiers, and they usually are used to handle large voltage signals. Then the classification of power amplifiers we have discussed. That is class A, class B, class AB, class C, and class D power amplifiers in detail. That is considering few points on class A, class B, class C, class AB, and class D power amplifiers. Okay. Then next we discussed efficiency of these different types of power amplifiers. That is efficiency of class A, class B, class C, class D, and class AB power amplifiers. Okay. The next class will continue with the first type of power amplifier, that is class A amplifier. We'll discuss about its DC analysis, how it operates, and the AC analysis. Okay, so that biasing conditions will take up for the class A type of power amplifiers in the next class. Okay, any difficulty here, students, in today's class? Any difficulty here? Any difficulty, students?
No, sir. No,
Is
sir.
it understood that today's topics?
Yes, sir.
Okay, Ankita.
No doubt, sir.
No doubts. Fine. Sai Prakash.
Yes,
Any
sir.
doubts, Sai Prakash?
No, sir. No doubts.
Okay. Shubham, any doubts?
No, sir.
Fine. Suraya Banu.
Yes, sir.
Any problem in understanding Suraya Banu?
No, sir.
Okay. Ilyas,
No, sir. No doubts.
fine. Shweta,
No, sir.
okay. Prajwal,
No, sir.
any doubt? Prajwal,
No, sir.
okay. Karthik Patil, Karthik, Sampath,
No, no doubt, sir.
no doubts. Any problem in understanding, Sampath?
No, no, sir.
Any difficulty?
No, sir.
Okay, fine. Okay. Then we'll continue with the class A type of power amplifier in detail in the next class. Okay. Thank you.